Now, plants get H and O from water. They get carbon from the carbon dioxide in the air. So those are taken care of. We've got those three. Next, big macronutrients. We need lots of those. And then these ones are called micronutrients. Macronutrients. So those three it gets from water and the air. Carbon dioxide from the air, H and O, water. So what do you give a plant? Water and air. And some. Now, where does it get the next pK and N from? That's what this section is about. Where do plants get their pK and N from?
The soil.
The soil. Okay, so anyone can go up to the soil, dig your finger in, drop a seed, leave it, and that seed will come up. But then there's no guarantee it will fire. We've got to show our soil contains P, K, and N, especially. So what are you going to do, especially if you're doing hydroponics, which has got none of those? You've got to give it something. What are you going to give it? To make sure soil is nutritious, you're going to give it plant food fertilizer. Okay? So, on this bag of garden care plant food, which I don't get any much promoting, it says 3, 1, 6, 46. The average layman doesn't know what that means. This is what it means. Thank you.
It's the ratio of PK and N.
So the ratio of PK and N. Lovely. Did you know that? That's not a guess? You know that. Okay, so which is the N here?
No one.
This is the N-P-K ratio. Weight. 3 parts of the weight is nitrogen, 1 part is phosphorus, and 6 parts is potassium. Okay. Now 46%. Matthew, what is the 46 for? Now for a cheapskate, this is the first number you look at. That's the first number I look at. It's the percentage of the weight of this. This is 500 grams. But this is the percentage that is NPK. The percentage of actual fertilizer. So, who can work out with a calculator what amount of actual fertilizer I'm getting for my money? I'm not getting 100% for my money. I'm getting 46% of what I paid for. So what's 46% of 500 grams? Well, it would be 250 grams. Is it exactly 250? Okay, so I can say 250 of that 500 grams is actual fertilizer. Now, Matthew, of that 230 grams, or not just Matthew, anyone, how much is nitrogen? So look, we've got a ratio. 3:1:6. 3 parts of this is nitrogen. So how much grams of nitrogen is that?
69 grams.
How many?
69 grams.
69 grams is nitrogen.
Okay.
How much is phosphorus?
23.
23 grams. And how much is potassium? 138 grams. Let's add them all up. 9, 10, 11, 12, and 8 is 20. Carry 2, 5, 6, 7, and 6 is 13. 230. Exactly. So now we know that Matthew worked it out correctly. So how did you work that out, Matthew?
I added the ratio, all the ratios together and divided 230 by the ratio.
He added 3 and 1 is 4 plus 6 makes 10 parts. Then to divide 230 by 1 is easy, it's just 23. Then you multiply the 23 by 3, you get 69. Then you take the 23 and you multiply it by 6, you get 138. There you go. Well done. Who would like us to say that again? Because this is the kind of question they ask in the exam. The textbook covers it a little bit on page 244, a tiny little sentence in paragraph 244, but this is what textbooks cannot do. Textbooks cannot tell you what past exams have examined on, but this is what past exams examine on. They will give you this and they will ask you what percentage of the 500 grams is nitrogen, phosphorus, and potassium. And so, Kezia, this is what we do. We first take the 500 grams and we work out what is 46% of it. That's the first thing we do because we want to get down to the actual mass of fertilizer. Then, knowing that 46 over 100 times 500 gives us 230. Now we add this up, the parts. In this case, it's nice because it adds up to 10. So then you say 3 out of 10 times 230. 3 upon 10 times 230. 3 out of 10 parts is nitrogen. 1 upon 10 parts times 230 is P, and 6 out of 10 parts is potassium. So that will be one question they will ask you. Now the next question they're going to ask you is, what would this fertilizer be good for? And here's what you've got to know. You've got to know that nitrogen is good for leaves and green, anything green. So would this be, for example, something that needs nitrogen? Would that need nitrogen?
Yeah.
It's a green leaf. Let me tell you the only way I've killed plants hydroponically. If I left this and day after day I just give it water, eventually, you know what color this goes? Yellow, non-green. When I see this going yellow, I give it some plant food. The only way I've killed plants before, giving them too much, because this stuff burns the plant if it's too strong. So always give less than you think. You can always give more later on. So this is the kind of plant that I would say, this is great. It's got 3 parts of nitrogen. This is good food for this plant. Now we come to N. Now we come to P. Now what is P good for? Well, I look at the shape of the P. And I see the ground, and I see this P growing into the ground, and I see, what am I drawing here? A root. The P looks like a root. So for root crops, phosphorus is very important. Are you never going to forget it? Okay. P looks like a root, and it's good for roots. Then there's one little part of it, and that is K. Now K, what does that look like? A flower. So now I remember K is good for fruits and flowers. So this would be exceptionally good for your strawberries. Your strawberries would love that. My plant would love something that's got a higher N. Like lawns will just like N. They don't want anything really else. And K also helps a little bit with disease resistance. Okay, so I think of K for calyx of the flower, or I just make this into what looks like a flower. Okay, so now you know what the various nutrients are used for. That is on page 243. Yeah. Overall plant health, it helps the plant resist frost, drought, and some diseases. K. I'm afraid, you see, there's where your textbook lets you down. K is for fruits and flowers. Your textbook forgot to mention the most important thing. Under phosphorus, it says stimulates root and flower development and growth. But P is mainly for roots. Okay. Now, other fertilizers will look like this. 3, 1, 1, or 1, 5, 1, or 1, 2, 6. And then they're going to ask you, match this with beetroot. You're growing beetroot, swish hard. And mulberries. So which one is going to be good for Swiss chard, or which is like a spinach?
What is it?
Sorry?
What is a Swiss chard?
Spinach.
A spinach.
Like a green spinach, Swiss chard. Just say spinach. So which of these are going to be good for Swiss chard?
3, 1,
3, 1,
That one. Which is going to be good for beetroot?
1, 2, 3.
1, 2,
1 to 6.
1 to this one.
Yes.
For beetroot. Or
No, 1,
because
5,
they
1.
have the bigger roots. The bigger.
1, 5, 1.
the P is for the root. So this is a root crop, so you want the second one. And then mulberries are a fruit crop, and then you're going to use that. All happy? Okay. Then, so that's the kind of question they're going to ask. Oops. There's a leaking here. Then, they're going to ask you how. First of all, in what form does the fertilizer come? You don't, fertilizer doesn't come in nitrogen or phosphorus or potassium. It doesn't come like that. It comes in a certain type of form. Anyone heard of fertilizers? And they can give me a name. So fertilizers, is it okay if I rub this out? Right? Okay, fertilizers come in a form they come in this form. It comes, nitrogen comes in the form of ammonia, or in the form of nitrate. Phosphorus comes in the form of PO4, phosphate. And the potassium comes like potassium phosphate. So K to PO4. Potassium comes with one of the others, or potassium nitrate. So phosphate is 2 minus, nitrate is 1, and normally it comes ammonium. Ammonia is NH4. What is it? Is it minus or plus? Ammonia. Plus. Must be. Yeah. Potassium. Right. I'm having a slightly grey moment. But anyway, it's either plus 1 or minus 1, but I'm sure it's a plus 1. Okay, so it comes in those forms. Now, where do we, for example, get ammonia from? NH4 plus. Well, you'll find it on page 244. 244. I'll stop in a moment. Nitrogen, anyone know a big source of nitrogen that's all around you?
The atmosphere.
The air is what percentage nitrogen? 79%. So there's the source of nitrogen for you. 20% oxygen and 1% CO2. It's not, it's 5.5% CO2. So air is 79% nitrogen, 20% oxygen, and it's 0.5% CO2. It's a tiny amount of CO2. Now, I call myself a scientist, nobody else does. But as a scientist, did you know that if you examine a fossil record, the amount of carbon dioxide in the air has sometimes been up to 10, 20 times more than it is today? The fossil record says it was much higher in the past. So when scientists like Greta Thunberg, which I really think she's fantastic, say we are killing our planet with greenhouse gases, especially carbon dioxide, I think to myself, is all the science wrong? Which, if you go into the paleontology and the record, during, for example, the Carboniferous era, it was 10 times or more, 100 times more carbon dioxide in the air than today. So this is why I have an open mind whether the carbon in the air is the biggest problem. Because we can measure through fossil history, it was much higher and nothing died. Or should I put it this way, humans weren't around. Maybe it'll kill us, but the dinosaurs and the creatures that lived during the Carboniferous, they survived happily. It was lovely and warm. Those things liked warm. Okay, but I digress. And I want to just finish off. So we get our nitrogen from the air. Anyone know how we can get nitrogen straight from the air? Breathe. You freeze it to minus 200 and it freezes into a liquid. Then you warm it a fraction and all these gases, the oxygen stays frozen and the nitrogen boils off at about minus 100. They give the temperature minus 196. The nitrogen boils off first and then you catch it and all the oxygen is left behind. Then you bottle that oxygen, you send it to the hospital. They will put you on a respirator if you've got corona, or a ventilator, should I say. That's where they get their oxygen from. Fractional distillation of air. Fractional distillation of air. And last of all, before I finish, anyone know where you get hydrogen from? That's a good idea, but they get it from coal. Sasol and other companies, they, it says here, hydrogen gas, H2, is manufactured at Sasol in South Africa from coal, natural gas and steam. And this is called the Fischer-Tropsch process. That is a name worth mentioning, the way they obtain hydrogen gas from coal. The Fischer-Tropsch process. I can't spell that. T-R-O-P SCH process. So in the Fischer-Tropsch process, they get hydrogen, and in fractional distillation of air, they get nitrogen. Then they combine the two in a process called the Haber process, where H2 plus N2 goes to form NH3, ammonia. Haber process. All those processes you need to remember. But it's fun, it's easy, it's not hard. You read it once or twice, you'll know it. And guys, don't make this mistake. Don't say the section is so easy that you don't revise it. I want you to especially revise what you find easy. Did anyone find this section difficult? It's easy. It's like life science. But because it's so easy, students focus on all the hard stuff and they forget the easy stuff, and then they lose the easy marks. And just my last sentence is, for example, I tried for 4 years to play the piano. What a waste of time. I still can't play the piano. Don't focus on something hard. Maybe I should have focused on something easier. Find something that's easy, you're good at, and then do that. Don't waste your time on difficult stuff. That's my advice. Okay, you want to carry on then with writing up your practicals? Has everyone got something to write up? To write?